The function g of x is a piecewise function, and we want to find the limit of g of x when x approaches to 1. So if you notice that the function g of x, if we plug in 1, the function g of x when x equal to 1 is pi. But the limit is not equal to pi because we are not finding the value of g of x when x equal to 1. We are finding the limit when x approaches to 1 for the function g of x. So this is a little tricky because this is a piecewise function. This is not a polynomial or rational function. So if you do the graph, the top one is you begin from 1 on the y, and then the slope is 1, so you go 1 up and 1 to the right. So you get this line. And also, when x equal to 1, the function is not defined from the first piece. So this one is the first piece. So I'm gonna make the pink color for the first piece. And when x equal to 1, the g of x equal to pi. Pi is like 3.14, so it's like this. So when you approach to 1 from the left side and from the right hand side, from the picture, from the graph, you can see that g of x is approached to 2. Okay, so the limit when x approaches to 1 of the function g of x is equal to 2. And how do we get the 2? We plug in one value into the first one, so which is in the pink line. So we got the answer is 2. Example number 5. If we just simply right now plug in h equal to 0, we will get undefined. So we need to find the limit when the function is well defined at a value. So we need to do some algebra to fix this function. So we need to think about this as like the function f of x. So we need to make the function f of x become a function g of x so that the function g of x is well defined at h equal to 0. Okay, so we're gonna do some algebra for that. Now we do limit of h approach to 0. What about we open the parentheses? So we get 9 plus 6h plus h squared minus 9. Then we can cancel out the 9 on the top, and also we can factor out the h. So we get h, and then 6 plus h over h. So we got limit of 6 plus h when h approaches to 0. So this is the function f of x, and it is the same as the function g of x, and they both well defined when x approaches to 0, when h equal to 0. So they both well defined at h equal to 0. Now you just simply plug in 0 into the h. So you get 6 plus 0, and the answer will be 6. The next one is similar. If we plug in the t into the function, we will get undefined. So what should we do is we need to fix this function. We need to do some algebra for this. So we see the square root. Yeah, we learned the square root before. So what about we multiply by the conjugate so that we can get rid of the square root on the top, and we need to fix something in the bottom so that we don't have only t only in the bottom, because if it's equal to 0 we get undefined. So what I'm going to do is I multiply by the conjugate, so t squared plus 9 plus 3. So on the top, I use the formula a plus b a minus b, and I got a squared minus b squared. So I will get t squared plus 9 square root, and then square this minus 3 squared divided by t squared times square root of t squared plus 9 plus 3. Then it will equal to t squared plus 9 minus 9. So you can cancel the 9, right? And t squared square root of t squared plus 9 plus 3. So you see t squared and t squared, you can cancel more. So you get 1 on the top. So I forgot the limit. So I need to put out the limit in the front. So it's equal to the limit of t go to 0. Limit of t go to 0. And it's equal to the limit when t go to 0 of 1 over square root of t squared plus 9 plus 3. Now it is okay for us to plug in the 0. So we have 1 over 0 squared plus 9 plus 3. So we got 1 over 3 plus 3, right? So 1 over 6.